Hi everyone, now we will start with chapter 3, that is inequalities and absolute values. In this video, we will look at subtopic 3.1, inequalities, and the objective of this lesson is for us to understand the basic concept of inequalities by using number line. What is number line? In math, a number line can be defined as a straight line with numbers placed at equal intervals or segments along its length. Straight line. A number line can be extended infinitely in any direction, depending on the question, either to the left or to the right, and is usually represented horizontally. So it roughly looks like a ruler, and your number line over here, numbers on the left, if you notice, will always be smaller than the numbers on your right. Symbols in inequalities. We have 4 symbols. The first symbol over here refers to less than. The second symbol means greater than. The third symbol is a little similar to our first symbol just now with a little extra dash below, and it means less than or equal to. The little dash below also means equal to, and the last symbol is greater than or equal to. Examples of inequalities. I give you 4 different examples here. And why are they inequalities? We look at the symbol. This is greater than, this is less than or equals to, this is a combined inequality with the symbol less than and also less than or equals to. And the last one, it is greater than or equals to. If we have any of this symbol, then it is an inequality. But if we have this equal sign, then this is not an inequality. Now we're going to learn how to represent inequalities by using number line. So from just now, we know that number line is a straight horizontal line consisting of numbers. So for this question, x greater than 4, I will draw a number line first. And then I have this number 4. On the number line, 4 is going to be a point. Okay, 4 is going to be a point. So we have a little note over here. We have 2 types of point. The first type is the open point. A point is said to be an open point if we have the symbol greater than or less than. And this is how we draw our open point. A dot, an empty dot in the middle. Now, the second type of point is what we call a closed point. The point is a closed point if the symbol used is greater than or equals to or less than or equals to. And this is how my closed point will look like. Also a dot, but this time I'm going to shed the middle part. Okay, so this is how my closed point will look like. And this is how my open point will look like. So now we go back to example A, x greater than 4. So I have a point. So I'm going to draw a point first. Now this symbol is greater than. So if it is greater than, then it's going to be an open point. The point will look like this, not shaded in the middle. Then I now look at the inequality. It is greater than. If it's greater than, my number line is going towards the right. Because if you look at your ruler, any numbers on the right is always bigger. So x bigger than 4, it is going to the right. This is how my number line will look like. Now for example B, m less than or equals to 2. So I draw my number line, a straight line. This time I have the number 2. And 2 is a point on my number line. So what type of point is this? We look at the inequality. It is less than or equals to. So this point is going to be a closed point. So I have to shade the middle part. This is how my point is going to look like. And now it is less than or equals to. If it is less than, my number line will go to the left because numbers on the left is always smaller. So this is how my number line for m less than or equals to will look like. My next example is a combined inequality. So for combined inequality, we will always use the symbol less than. And now I have j in between -2 and 4. We will now draw our number line. We start with the smaller number first on the left, that is -2. And here I have 4. These two numbers will form a point. So what point will -2 be? Because the symbol is less than, so it's going to be an open point. Whereas this one over here, number 4, this one is less than or equals to, so it's going to be a closed point. So 4 will be a point that is closed, shaded in the middle. And j between -2 to 4 means that the numbers are between -2 and 4. So I just connect them with a straight line. This is how the number line will look like. Okay, example D, r is greater than or equals to -1. So to draw number line, again, I draw a straight horizontal line. The number is -1. This time I only have 1 point. Not like just now. Just now I have 2 numbers, so I have 2 points. But this time I have 1 number only, so I will have 1 point. What point is this? I refer to the inequality. It has an equal sign, so this is a closed point. So I will shade this point, and now I'll look at the direction. It says greater than or equals to. If it is greater than, then the number, it will go to the right-hand side, because number on the right is always bigger. In the previous slides, we have learned how to draw number lines. So coming up, we're going to learn how to express inequalities as interval notation and also solution set. For interval notation, we will play with brackets. I have 2 types of brackets, that is the open bracket and also the closed bracket. This is how an open bracket will look like. And this is how a closed bracket will look like. We will use open bracket if our symbol is greater than or less than. And we will use closed bracket if our symbol is greater than or equals to, less than or equals to. For solution set, I will play with curly bracket. And also I need to consider the variable, okay, depending on the question. In the previous slides, we have already learned how to draw number lines. So coming up, we will try some examples to express inequalities in interval notation and solution set. So for the first question, I have 6 less than x less than 9. My interval notation, I need 2 numbers. So the numbers are 6 and 9. For interval notation, the smaller number will be on the left and the larger number will be on the right. So 6 is a smaller number, so it will be on the left, so 6, 9. Then I will play with bracket. To play with bracket, I look at the inequality. At 6, the inequality is less than. There is no equal sign, so this means that it will have an open bracket. So there's an open bracket at 6. And now at 9, the inequality is less than. So this is also an open bracket because there is no equal sign. So at 9, the bracket is open bracket. Next, I will do my solution set. Solution set is easier because first of all, I need a curly bracket. So I do my curly bracket. Then after that, I will check what is my variable. In this case, my variable is x. So I will write that down, x double dot. Then after that, I just copy the entire inequality. So this is 6 less than x less than 9. So for solution set, I need curly bracket, I need the variable double dot, and also I copy the inequality. Right, question number 2. This time I have -2 less than or equals to m less than 0. Now my interval notation, remember what I said just now, smaller number on the left and larger number on the right. So -2 is a smaller number, so I have -2 on the left, comma, 0. Then after that, I will do my bracket. So I look at the inequality at -2. The symbol here is less than or equals to. So it has an equal symbol there. So it means that this will be a closed bracket. So I have a closed bracket at -2, my closed bracket. Then I look at the inequality at 0. The inequality here this time is less than. There is no equal sign, so it means that it will be an open bracket. So at 0, it is an open bracket. And now I will do my solution set. So for solution set, I will have a curly bracket. And then my variable this time is, m. So I'll write that down, m double dot. I'll copy the entire inequality. -2 less than or equals to m less than 0. Now we will combine all the things that we've learned just now, that is number line, interval notation, and solution set. More examples. This time we will draw a number line. We're going to state the interval notation and also solution set. My first inequality is x less than -2. I will draw my number line. The number is -2. It will form a point. So here the point is an open point because the inequality is less than. There is no equal sign, so the point is open point. And now we know that the symbol of the inequality is less than. So this means that the point is towards the left, because numbers that are smaller will go to the left. X is smaller than -2, so the point moves to the left. Now for interval notation, I need two numbers on the left and also numbers on the right. So from my diagram here, from my arrow here, I need to find a number on the left and number on the right. And here it seems that -2 will be on the right. So I have -2 on the right. What's the number on the left? There is no number on my number line. However, from my arrow, I can see that the numbers are getting smaller and smaller and smaller. How small will it be? We don't know. So it means that this number going to the left at one point will approach a negative number that is very small, which I can write as -infinity. And the last step for interval notation, I need a bracket. So -infinity is not a number, so this means that the bracket will always be open. And as for -2, this is an open point, so the bracket has to be open. Finally, for solution set, this is equals to curly bracket. And now I'm going to check what variable they are using. The variable here is x, so x double dot, and I'll copy the inequality, which is x less than -2. Second example is x greater or equals to 12. So I'll do my number line first. Number line, the only number here is 12. And looking at the inequality, I know that this is going to be a closed point because it includes an equal sign. The inequality here is greater than or equals to. So it is a closed point pointing towards the right because the inequality says that it is greater than. Numbers on the right are always bigger. Okay, that is my number line. As for interval notation, I need two numbers on the left and numbers on the right. So looking at my arrow, I need numbers on the left and right. So here I know that 12 is on the left, so I can write 12. Now on the right, there is no number on the number line, but my arrow says that the number will keep on increasing. The number will keep on getting bigger and bigger. I don't know how big it will be, but it will get so big until at one point I can write it as positive infinity. So on the right here, I have positive infinity. Final step for interval notation, I need a bracket. So at 12, the point is a closed point, so this is a closed bracket. Positive infinity is not a number because if it is a number, we can find infinity on our handphone, on calculator, but it is not a number, so I have to use open bracket. And lastly, for solution set, this is equal to curly bracket. The variable this time is x, so x double dot. Next step, I will just copy the entire inequality, x greater or equals to 12. So that's the solution set. Okay, for example C, this is a combined inequality. I have -5 less than or equals to x less than 8. For number line, I have two numbers this time that are -5 and 8. So smaller number first on the left, so -5, 8. Next step, I will determine the point. At -5, the point is a closed point because the symbol at -5 is less than or equal to. It has an equal sign, so it is a closed point. At 8, the symbol is less than, there is no equal sign, so it is an open point. So since I have 2 points here, and the inequality here means that the number x, the variable x, is between -5 to 8, I will just connect these 2 points. Okay, so it means that the numbers are between -5, it will include -5 also, and all the way up until 8, where it does not include 8. So for my interval set, I need two numbers, smaller number on the left and larger number on the right. So -5, 8. At -5, the point is closed, so I have a closed bracket. And at 8, the point is open, so open bracket at 8. Now for solution set, I have a curly bracket. Then I check what variable do I have. My variable is x, so x double dot. And final step, I just copy the inequality. -5 less than or equals to x less than 8. For the last part of our video, we will talk about the concept of union and intersection. I will start with union first. This is the symbol for union. Remember the first letter, so you will know that this is the symbol for union. In maths, union means or. Or in other words, if I have the symbol union, it means that I'll take into account everything. For intersection, this is the symbol. And in maths, intersection means and. And the idea of intersection is where to meet. We will look at a few examples after this to further understand the concept of union and intersection in number lines. For this question, I have a equals to -3, 4 with open brackets at both ends and b equals to 2, 6 closed brackets at both ends. Express A union B and A intersect B as a single interval in the form of interval notation and solution set. So now to draw these two number lines, because I have the symbol union and intersection, I will now need to draw both of these number lines A and B on the same scale. So I have a horizontal axis. Then notice that I have four numbers here. They are -3, 4, 2, and 6. Now on this horizontal axis, I will arrange these four numbers in such a way that the smallest number will always be at the left-hand side. So I have -3 followed by 2, 4, and 6. Now I can start to draw my number line A. So at A, I have -3 and 4. So I have 2 points at -3 and 4. These 2 points are open points because my brackets here are open. So now they are open points. I can connect these 2 points. So I name this number line A. Next, for number line B, I have 2 numbers. They are 2, 6. So I have 2 points at 2, 6. At 2, the bracket is closed. At 6, the bracket is also closed. So the points 2 and 6 are closed points. Now combine these 2 dots. This is my number line B. I have already drawn both number lines A and B. So now I can answer A union B. So for union, I play with everything. So everything means that over here, I will consider both number lines A and B. So when we do union, we always consider the point at the smallest number first. So at the most left-hand side, my point lies at number -3. Consider everything, so we will move to the right. Okay, move to the right, this is number line A, then it stops. But because I have a number line B below and I consider everything, I will continue the number line B until it will finally stop at the point at 6. So now my interval notation is equals to, I need 2 numbers. I have numbers -3 and 6. Smaller number first, so -3, 6. Next, I will play with brackets. To play with brackets, I look at the point at -3. At -3, my point is an open point. So this means that my bracket will be an open bracket. And at 6, my point is a closed point. So my bracket will be a closed bracket. That is for interval notation. We look at the point to determine our bracket. And now for solution set. Solution set, first of all, I have a curly bracket. Then I need a variable. But in this question, there is no variable. So I can freely choose any random variable. Let's say I choose x. So I have x double dot. In our previous examples, we just copied the inequality given. But in this question, inequality is not given. So what I can do is, we look at our interval notation. Okay, we look at our interval notation. From the interval notation, we can build our solution set as well. So 2 numbers. I do number -3 first. Now look at the bracket at -3. The bracket at -3 is an open bracket. Open bracket means that there is no equality, so I have the symbol less than. Less than, this is a combined inequality, so I have x. Then the next number is 6. Okay, see the bracket at 6. The bracket at 6 is a closed bracket, so the symbol must have an equality. So the symbol here will be less than or equal to. That is for A union B. Now for intersection, A intersect B. Intersection, we always play with where they meet. They here refer to the number line. They here refer to the number line A and B. So you look at our number line A and B. Where do these 2 number lines meet? So you look at where the red and blue lines meet. They will meet at this region. Okay, this is where the red and blue line will meet. So they will meet at 2 and also until 4. So now I have 2 numbers there, 2 and 4. Smaller number on the left, bigger number on the right. At 2, we see what is our point. At 2 here, my point is a closed point. So my bracket will be a closed bracket. And at 4, my point here is an open point. So the bracket will be an open bracket. Now we do for our solution set. So solution set, I have a curly bracket. Like just now, the variable is not given, but since I used x just now, so I will use the same variable. I'll be consistent, so I'll choose x again. X double dot. Inequality is not given, but I can build my solution set from the interval notation. So I look at my interval notation. I have the numbers, the smaller number first, that is 2. Look at the bracket at 2. It is a closed bracket. So the symbol will have an equality sign. So this is less than or equals to. This is a combined inequality. So I have x. The next number is 4. Look at the bracket at 4. Open bracket. So open bracket means that it is just less than. This is for my A intersect B. We will now try more examples. For this example, graph the following intervals and write the resulting intervals. Over here, I have two intervals combined with a union. So first of all, I will draw this interval first. But before that, since I have two intervals, I will have to draw a horizontal axis first. There are four numbers, -4, 0, -2, and 2. I will arrange these four numbers in such a way that the smallest number will always be on the left-hand side. So I have -4, -2, followed by 0 and 2. Now I will draw my first interval that is from -4 to 0. Two dots here, 2 points here, and these 2 points are open points because you look at the brackets at -4 and 0, they are open brackets, so that means they are open points. So I combine these 2 points. That is my first interval. Now my next interval is from -2 to 2, so I have -2 to 2, 2 points. Look at the bracket. The bracket at -2 is closed bracket, so here is a closed point. And the bracket at 2 is an open bracket, so open point. Combine these 2 points. And now I will try to solve the question. The question here wants union. So if union, we will consider everything. So from my number line, if they want everything, I will always see the smallest number first. The smallest number happens to be where the point is, that is -4. And then I will continue to the right hand side with my red number line on top, and then it will still continue because I want everything. There's a green number line below. It will continue until it finally stops at the point 2. So now my interval is, my resulting interval, I have two numbers, smaller number on the left, so it is -4, 2. As for the bracket, look at the point -4. At -4, here, my point is an open point. And at 2, my point is also an open point. So there I know what is my bracket, -4 open point. So it will be an open bracket. 2 is also an open point, so open bracket. Okay, for this example, again, I have two intervals combined with an intersection. So first of all, draw my horizontal axis first. I have, over here, I don't have 4 numbers, I have 3 numbers because -infinity is not a number. If -infinity is a number, then we will see that -infinity on our handphone, on our calculator, but it is not a number, so I won't consider -infinity on my number line or on my horizontal axis. So I have 6, 3, and 10. Arrange the smallest number, that is from 3, 6, 10. So first of all, I will draw this interval, -infinity to 6. So -infinity is a small number, very, very small, heading towards negative number. So it will be at the most left until it stops at 6. Okay, I have a point at 6. Now at 6, the bracket is closed. So I will have a closed point. The interval from -infinity to 6, it means that the numbers will be getting smaller at the left hand side. Left hand side, it will approach -infinity. So this is my interval. For the next one, I have 3 to 10. So 2 points because 3 and 10 are both numbers. So 3, 10. 3 has an open bracket, so that is an open point. 10 has a closed bracket, so closed points. Now I can combine these 2 points. And I can now try to solve. This is intersection. Intersection means where they meet. So when do these 2 red and green lines meet? They will meet here at this region. from 3 to 6. So now resulting interval, two numbers, smaller number first, 3, 6. Look at the point at 3. The point at 3 is an open point, and the point at 6 is a closed point. So with that, I can do my brackets. So 3 open point, open bracket, 6 close point, so close bracket. That is my resulting interval. Okay, for this question, I have two intervals combined with an intersection. So first of all, I will draw my horizontal axis. Here I have four numbers, arrange them from the smallest to the largest. So I have -1 followed by 2, 3, and 8. I will do my first interval first, that is -1 to 3. So 2 points here, -1 to 3. -1 is an open point because the bracket at -1 is open. 3 will be a closed point because the bracket at 3 is a closed bracket. Combine these 2 points. And now next I will do for the second interval from 2 to 8. So from 2 to 8, I see the bracket. 2 is an open point because open bracket. 8 is a closed point because it's a closed bracket. Now combine these 2 points. So that's my number line. Now I'll consider the symbol intersection. Intersection means where they meet. So where do these two lines meet? Look at both my number lines and I see that they meet at this region from 2 to 3. So now my resulting interval is equals to smaller number on the left, that is 2 to 3. Look at the point at 2. It is an open point, so open bracket. 3 is a closed point, so this is a closed bracket. That is my solution. Here are some exercises for you to try. You may pause the slides while trying them. Here are the solutions to the questions just now. This is the end of our video. Thank you very much for listening.